Hello, my name is Drew Young. In this presentation, I'll be talking about the research done by this study that uses data mining techniques to better understand how powered two-wheelers maneuver around corners and curves. Powered two-wheel vehicles are at a greater risk of injury and death. They face an increased risk on sharp curves and bends. With the data provided by this study, we can help determine why there's a greater risk and what can be done to decrease the risk as these vehicles become more popular. In this study, the focus is on analyzing curve entry of the bin by using an unsupervised framework. This is an algorithm designed to analyze and make assumptions about the data without any prior knowledge about it or the relationships between the different variables. The powered two-wheelers are being examined on a track around set bins, so it becomes important to use a tool like this to be able to make different assumptions that a human observer might overlook and allow us to find patterns and behaviors that can be applied to other conditions. This study had a set of three different instructions for the riders. One instruction being free riding, where they're just riding normally, as they normally would. Another was body riding, where they would ride with their body as much as possible. And the last was handlebar riding, where they use the handlebars as much as possible. To better understand and analyze the data needed to be split up into four segments of the bend. Since the focus of this study was only the entry into the bend, the data being considered is the data from the first segment going into the second segment, which is further deconstructed into the straight driving and the curve initiation. When studying these two segments, they discovered that there is more variation beginning in the curve initiation rather than in the straight driving before. This means they were successful in grouping similar behaviors and can identify variations in behavior within the subgroups. Knowing that the variation begins in the curve initiation in segment 2, the focus shifted to the segment to identify and interpret the diversity seen happening to see what factors contribute to the rider's behavior during the initiation of the bin. The study used HAC, which is a clustering algorithm used in unsupervised machine learning that merges the most similar clusters into a single cluster containing all the data points formed. Using these algorithms on the data in the second segment, clusters of data with similar behaviors are identified using 9 observed variables that contribute to the rider's safety and comfort. By analyzing the relationship between the different clusters of drivers, they were able to make assumptions about the riders. The riders in cluster 5 had a high variability in role dynamics than the riders in cluster 4, and they tried to correct themselves by using handlebar steering, while cluster 4 riders did not need to adjust their position as they were already having an optimal approach. This data allows us to read into different behaviors of the riders and the vehicles of the bend, and we can use this data to come up with better solutions that take these behaviors into account and develop more effective safety features, leading to reduced accidents and fatalities, making these powered two-wheelers safer on the road.